Hello, this is Subaru. I'm going to talk about how containers have been utilized in computer science. Previously, we explored what boxes and containers do in the physical world. This article shifts to the virtual world, how containers are used in software and on the internet. First thing first, quick recap. What containers do? Container equal a portable place that preserves original value. It encloses complexity, protects what's inside, and packages requirements so they can be delivered efficiently. So today's journal, from physical to virtual, will explore how containers are used in software development, internet infrastructure, and modern computing. Let's see how the same principles apply in the digital world. Sorry, I forgot the presentation order. Here is the quick recap again. Uh, Container is a portable place that preserves original value. For things I have in mind, and it encloses complexity. It protects what's inside, and it packages requirements. It delivers efficiently. Same concept, different implementation. When you hear When container is mentioned in software, most people think of Docker. Docker made containers easy to use and on a host OS because a container shares the host kernel and borrows some resources such as CPU and RAM and files. It starts far faster than a virtual machine in terms of borrowing your host OS. It requires less time to boosting. Here is the Docker abstraction in 1 minute. It had three, three core components: CLI, daemon, runtime. The Docker CLI talks to the Docker daemon, which uses a runtime to start containers. And how do we get the packages? The packages, so-called images, reside in registries. When we run some Docker CLI commands, such as Docker pull images, we pull that from the registries. And third, only three commands are required to start a server. Pull, 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 build, run. Here is the Docker high-level architecture. It composes three, three components: client, daemon, ru- uh, client, Docker host, registry. Mostly, we communicate Docker with their API using Docker CLI command. Uh, Here is the brief explanation for each component. The Docker client, we use we send commands over REST API which are served by Docker. And the Docker daemon, it is orchest it orchestrates builds and images and containers, such as systemd in a real systemd always observes our metrics uh, o- in our physical machine. Daemon refers daemon by means it's a longer running background process that waits for requests or events. Please check it on internet for further concept. And registry. It stores and serves images for pull, push, comment. Here is other concepts you should know when you want to understand other technologies used in the internet. Docker has core concepts. It helps you to understand other technologies used in the internet. Isolation and resource management. Namespace. Isolate what a process can see, adding some labels to process, such as PID, net, MNT, and so on. C groups limit how many resources it can use. CPU, memory, I/O, which is a main resource for personal computer, and layers and COW, which means copy on write. The copy on write refers to uh, copy on write has copy on write means that unless you require writing the data, you won't copy the data. It is so hard to explain the concept of the computer world, but copying on write means that CPU does not copy data. Even CPU has been requested to copy the data unless it requires to write its original data. This is the Wikipedia explanation. But it's totally clever to save your memory. More concept. Networking and security. Network drivers, bridge, sorry, those sentences are generated by ChatGPT and Claude Code. I couldn't grasp those concepts. Sorry. Next, in next time, I will see through those areas before starting presentation. So let's cut this slide. Then we align our knowledge let's move on to hands-on section. Docker has way easier, Docker serves way easier usability than other software. Let's see Docker in action. Please install Docker, Docker CLI before this section, but I move on to next. Docker build, please type this command to your terminal. And Docker run, yeah, please launch the server. Once you've finished building, and lastly, um, type call command onto your terminal. It was pretty right. It was pretty easy, right? The call command responses some messages that you wrote on the API. And other container. Let's move on to other container. A PC is also a container, a box that packs hardware and software. Inside the case, CPU, memory, disk port, and the PC hides the messy wires and steps. It gives you a simple screen and keyboard so you can work. When you press the power button, a tiny program checks the ports, then it hands control to the operating system. The OS sets the rules. It decides which app gets the CPU. It keeps apps in their own space so they do not break each other. It saves files on disk so your work stays after power off. In short, the PC bundles many parts and gives them a clean interface. The PC The PC also protects what is inside. You log in with a user. Files have owners and permissions. The firewall blocks bad traffic. If one app is noisy, the OS can limit it so others stay healthy. The PC is a stable base you can trust for long time because parts follow common rules. Like USB, files, and socket apps do not need to know every hardware detail. They talk to the OS, and the OS talks to the metal. That is why a PC feels like a big container that keeps many small containers in order. So think of a PC as a pod and a container as a shipping box. The PC runs the operating system. It owns the CPU, memory, disk, and the network card. It sets the rules, keeps time, loads drivers, and protects the machine. It is long-lived. It stays up for weeks or months and gives us a safe place to run apps. Here is the containers versus PCs, different scales, but has same concept. A container is just an app packed with the tools it needs. It is not a whole computer. It uses same operating system as a PC, so it starts first and stops first. We first built on image, and image is like a sealed box with our app inside. Then we start a container from what image? From that image. If something breaks, we do not fix the box. We throw it away and start a fresh one from the same image. That is why runs are repeatable. By default, a container does not keep data forever. If we need data to rest, we put it in a volume or a database outside the container. By default, it also does not talk to the outside world. If we want to accept traffic, we open a port and map it to the host. Like saying use door 3000. For safety, we give the container only the permissions it needs and avoid running it as root. The host can also limit CPU and memory, so one noisy app does not hurt the others. So the fit is simple. The PC is a stable base. The container is the unit we ship. Put business logic in containers and let the PC handle hardware, drivers, file systems, and security. When we need very strong walls, like running untrusted code, we can use a virtual machine instead. When we need quick rollout, easy rollback, and the same building dev and Prada containers shine. If you remember just one line, remember this. The PC is the both steady and in control. Steady and in control. The container is a box, portable and quick to move. So here is the key benefit. Here's all the key benefits. Why containers shine? It's portability, speed, isolation, efficiency, reproducibility, scalability. To sum up, container is a big idea than Docker. We see it in hardware and software alike. A shipping box, a PC that bundles hardware and OS, a VM, a process sandbox, and a Docker container. All of them do the same kind of job. They wrap something, hide the messy parts, protect the inside, give a simple interface to the outside, add a bit of identity, a name, a label, and make it easy to move, start, stop, and replace. The words are different. Still for box, firmware plus OS for PC, the kernel's rules for container, but the purpose stays the same. Keep things together, keep them safe, and make them portable. So think of your PC as a steady big container and your software containers as the small standard box you ship your apps in. Thank you. Yeah, previous demo is on my GitHub repository. So if you want to know further, please check it out. Thank you for listening.